Okay, so whatever we derived here for error propagation in multiplication, this is the final formula. So let's see if we can apply it over here in this example. So the length and breadth of a rectangle are this much. Calculate the area of the rectangle with error limits. So that means they are given a rectangle. So they are saying this is 5.7, but not exactly 5.7. It can be plus or minus 0.1 centimeter. And this is 3.4 plus or minus 0.2, which means your area will also have a plus or minus. So there will be a smallest area and there will be a largest area. So they are asking you to calculate the area of the rectangle with the error limits. That means you should remember z is equal to a into b. So a into b means this into this. So 5.7 into 3.4. So whatever that is, you have to calculate and then you have to write it in centimeters square. So 19.38. Okay. Then you have to remember this formula del z by z is equal to delta a by a plus delta b by b. That's what we derived. So that means delta z is what I want. Z is, we just now calculated it, 19.38. Delta A is 0.1 divided by A is 5.7 plus delta B is 0.2 divided by 3.4, which is B. That's all. Do this, you will get the delta Z. So you have to write your answer as Z plus or minus delta Z. That's all. So let's see if we can quickly do this. 0.0175. So 0.0175 plus 0.2 divided by 3.4, 0.0588. 0.175, sorry, 0.0175 plus 0.0588, this much. Multiplied by 19.38, so which is 1.478. Okay, 4786 something. So this will be in centimeter, right? Centimeter square, sorry. That's all. So that means we found the z and we found the delta z. So that means z plus or minus delta z is equal to 19.38 plus or minus 1.478, okay, centimeter square. There is something called significant figures which is coming in the next topic. So here I can see there is only one significant figure, right? So that, sorry, two significant figure, which means your answer should also have only two significant figure. Here I see one significant figure, which means this answer should also have only one significant figure. Okay, so this can be written as 19. So if I round it off, we will come to this in the next topic. So if I round it off, this is not bigger than 5. So that means 19 will remain as 19. Plus or minus, actually if I round it off to one significant figure, it will be 1. But if I write 1, I think it will not be very accurate. So I may have to take it as 1.4, or I have to round it off to two significant figures. Let's see what the book has done. Wait, because sometimes you will take one significant figure more. So 19.4 plus or minus 1.5. So that means they have not followed the significant figure here. So they have taken 19.4. Okay. Okay, nothing wrong on it. Sometimes we take some, one significant figure more than what is here. Okay. Maybe as we study significant figure, probably it will make more sense. Any doubts here? Okay, so if you don't have any doubts, I will go to the next one. So what we studied earlier was multiplication. Now you can do the same thing for division also. So you see a plus or minus delta a, b plus or minus delta b. And I can take a commonly out. Okay, so I would say you will follow the same method, and what you will get is you will get something like this. Do you want me to teach this theory, or can we go to the problem? Which one do you want? How do you want to do it? So they taught me in the school, I didn't understand means, then I can teach you this. No sir, I already understood this means, you can directly go to the numerical. What do you want me to do? Please respond properly. Subhaya, Prasanna, Devi, Bhumika. If you tell me, I can now do accordingly. No answers means what can I do? Okay, maybe I can quickly show you how to get that. You will get a better feeling. Propagation. Error propagation in division. So the interesting thing is you will get the same thing as your multiplication. So addition and subtraction will have delta A plus delta B. Multiplication division will have delta A by A plus delta B by B, which is equal to delta Z by Z. So when this goes to the top, it will become power 1 will become power minus 1. So this is where most of you will have some trouble. So that's why I thought I can teach you this. And there is something called binomial approximation, right? So when you have 1 plus or minus x, for example 1 plus x power n, and the x is very small compared to 1, you can write this as 1 plus nx, okay, because the higher order terms we will ignore. So something like plus x square, x cube, all those things we will ignore. So there is something called binomial approximation. It's a mathematical thing which is coming later. So for now I would say just imagine that you can take this n and put it inside this and you get two terms. So it's a easy way of doing approximation. So that means minus into minus, it will become minus to plus, it will become minus, minus to minus, it will become plus. 1 into b. So that means delta b by b. So this is a approximation, not exact thing. As I told you in the previous derivation, whenever you see delta A into delta B, it will be like 0 0.1 into 0 0.1, so it will become 0.01. So this means this entire thing can be ignored. Okay, again all these things are approximations. That's how we do these derivations, because most of the time we try to make the expressions simpler. So on this side I have z plus or minus delta z, which can be written as, I can take z commonly out, so I can write 1 plus or minus delta z by z. Why would I do that? Because I can say now, comparing this and this, I can say z is equal to a by b, and I can compare this and this, 1 is equal to 1 and delta z is equal to this one. Delta z by z is equal to, what this shows you is, even for division you will get the same answer as multiplication. Okay, but in your school exams, if they ask you the derivation, you should know how to do this derivation. Any doubts here? Anybody having any doubts, any steps? Please ask me your doubts. ஏதாவது புரியலனாக்கா கேளுங்க. If you have trouble asking in English, you can also ask in Tamil. No issues for me, right? But you have to ask the doubt. நீங்கள் கேள்வி கேட்டால் தான் எனக்கு தெரியும். அந்த டவுட் கேட்டிங்கன்னா தான் எனக்கு தெரியும். யாரும் கேள்வியே கேட்க மாட்டேங்கிறீங்க, பேச மாட்டேங்கிறீங்க. ஸோ ஐ ஃபைண்ட் இட் லிட்டில் பிட் டிஃபிகல்ட். புரிஞ்சதா? ஏதாவது புரியாமல் இருக்கா? ஓகே. No answers, so we have to keep moving. Voltage across a wire is this much and the current passing through it is this much. Find the resistance of the wire. So we have studied something called Ohm's law. V is equal to IR. So find the resistance. So R is equal to V by I. So that means we are giving an example for division method. So R is equal to V by I. So 100 divided by 10, which is 10 ohms. If I want delta R by R, then according to the formula it will be delta V by V plus delta I by I. Okay, so this formula I am rewriting it for this one. So that means delta R is equal to, R is found as 10, so multiply this, R is coming over here. Delta V is 5 by 100 plus delta I is 0.2 divided by 10. So do the simplification, you will get the answer for delta R. So 5 by 100 it will be 0.05. So 10, 0.05 plus 0.02. So it will become 0.07. So 0.07 into 10 it will become 0.7. It means your R should be, R plus or minus delta R should be 10 plus or minus 0.7 ohms. That should be your answer. So let's double check if the book answer is coming correctly. Yeah, 10 plus or minus 0.7. Okay, so we saw addition, subtraction, multiplication, division. Now we have error in power of a quantity. So what happens if you have something in the power? So the derivation is very simple. So take the a commonly out. So delta a by a. So as I told you, by approximation, you can bring the n inside here. So when you have a power p, b power q, c power r, you can add all of them. So p times delta a by a, q times delta b by b, r times delta c by c. Very often you will make a mistake of taking this as minus because you will think division means minus. But just now we studied division also, delta a, delta b, you have to do addition, delta a by b. So here will always be plus. Okay. in the book itself they are given that this is related to NEET 2013. Calculate the percentage error in the calculation of x. So basically percentage error means it's coming from your concept of relate. This is absolute error, this is relative error, and multiply by 100. That is your percentage error. So if I want delta x by x, according to the power formula, I will write it as 2 times delta a by a plus 3 times delta b by b. Here you will put a minus, which is wrong. You have to put plus. Power is 1 here, so that means you don't have to put anything. So delta c by c plus delta d by d. But what is the power here in the d? It's power 1 by 2. So that means you have to power 1 by 2. Sometimes if they give you cubed root, you have to put. So this is square root, so we are putting 1 by 2. Suppose if they are given cubed root, then you have to put 1 by 3. That's all. So find out from the given information. Delta A is 4%, which means 4 divided by 100. Right, so that's your relative error. 2%, so 2 by 100. Delta C is 3%, so 3 by 100. Delta D by D, so 1 by 100. So I can say 8 plus 6, 14, 14 plus 3, 17, 17, 17, this is 0.5, right? So 17.5. So that means the relative error for x is 17.5 by 100. But they are asking you to find the percentage error, which means multiply by 100. So always remember, percentage means you have to put divide by 100, but if you want to find the percentage, then you have to multiply by 100. So that's your answer. Yeah, percentage error is 17.5. Okay, so very easy, nothing very difficult. If you have any doubts, please raise your doubts. Okay, then a very important topic called significant figures. So the digits that are known reliably plus. So up to this, what we studied was errors and error propagation. Here we are going to study significant figures, something like rounding off. So the digits that are known reliably plus the first uncertain digit are known as significant figures or significant digits. Okay, for example, 6.67 into 10 power minus 11. So suppose if I give a number it's your G value, gravitational constant. Yeah. So what this means is somebody who measured this, they are very sure about this number, they are very sure about this number, but maybe they are having some doubt in this digit. So that means it could be 6 8 or it could be 6 6. So it can be plus or minus something, right? Point zero 0.01, something like that. So that means they are not sure about this digit. So that means you have to you have to take all the certain digits and then one uncertain digit. Obviously, you can say that the digits after coming this is very, very uncertain, so we will not consider them. So that means this, and this is questionable. So, but still, this will also be included. So that means we say it is three significant figures. Okay. So you may be thinking, sir, what happened to this one? Well, we don't consider this one. For significant figures, only this one. This is called order of magnitude. Okay, how big it is or how small it is, this one. But the actual numbers, these are all called the significant figures. So rules for counting significant figures. Let's take some examples, probably you will understand it better. The rules are actually given in the, I think, yeah, it's given in this table. So, but maybe we can do it along with the examples, so probably it will make more sense. See, when you have zeros, so when you have zeros towards the end before the decimal point, right, we will not consider this as significant figures. So only these things are significant figures. So that's why they given 4 here. 1, 2, 3, 4. You may be wondering, sir, why are you including the 0? Well, only the zeros, on this end is insignificant. These things are significant. So that means when the zeros are appearing between the numbers, it should be taken as significant figures. Okay. Initially, it may look confusing, but as you do some problems, I'm sure it will become very easy. 5213.0. So you see, they are not sure about this value. So it can be 0, it can be 1, it can be, 99299, 2.99, something like that. So that means 1, 2, 3, 4, 5. So that means actually I took this one. Okay, I took fourth one, yeah, 5. So that means here the significant figures will be 5 significant figures. Okay. This one, as I told you, two zeros are towards the end, which means this is only one significant figure. So that means it is 1 is correct here. This one, when you have something starting with 0, you will not consider these zeros as significant. Only this number will be considered as significant. So that means it's also having one significant figure. You can write this as 5 significant figures like this. So Parimala, any doubt? Says you raised a hand.
Excuse me, sir. What is the meaning of significant, sir?
Significant means it is like whether it is important or not.
Okay, sir. Thank you.
Okay, so significant அப்படின்னா இது வந்து is it a important number or not அந்த மாதிரி.
Okay, thank you, sir.
Yeah. So So if you have doubt, please raise it immediately and we can discuss it. So this is slightly confusing initially, but as you do some problems it will become easy, so don't worry about it. So here you can see 1, 2, 3, so that means 3 significant figures. Here, as I told you, you have to ignore the zeros, so it will be 6032. So 1, 2, 3, 4, so that means 4 significant. But this same problem, suppose if I had given it as 1.0006032, in this case, since you have 1 instead of 0, then all these things are significant. 1, 2, 3, 4, 5, 6, 7, 8. So that means this will be considered as 8 significant figures. அதே இது இங்க 0 இருந்தது அப்படின்னா, then you will not consider, we should not consider these zeros as significant. 1, 2, 3, 4. So that means only 4 significant figures. Okay, well. So as we do some more problems, probably it will make sense, but we can go through the rules here. All non-zero digits are significant. All zeros between two non-zero digits are significant. So that means you see 2008 means 4 significant figures. All zeros to the right of a non-zero digit but to the left of a decimal point are significant. So இது கொஞ்சம் கன்ஃபியூசிங்காக இருக்கும். ஸோ நல்லா பாருங்கள், we can discuss it in detail. ஸோ இங்கே பாருங்கள். ஸோ இந்த கொஷனில் இந்த zeros it is towards the end. So we will be considering only these 3 numbers. So this is 3 significant figures. If they say it is coming from a measurement, then they are very sure about the zeros also. When they say that it is coming from measurement, then we say that this is also sure. That means it should also be included as significant figure. இது ரொம்ப கன்ஃபியூசிங்காக இருக்கும், but don't worry about it. Okay, measurement ன்னு சொன்னாக்க it means that this is also sure ன்னு அர்த்தம். We are very sure about the zeros, அதனால it is significant. இங்கே measurement இல்லை, it's more like a calculation அப்படின்னா it can be 705, it can be 06, it can be 07, it can be anything. So அதனால we are not sure about this, so we say it is 3 significant figures. பட் இங்கே ஒரு டெசிமல் பாயிண்ட் வச்சுட்டாங்க அப்படின்னா இந்த ஜீரோஸும் சிக்னிஃபிகண்ட்டாக கன்சிடர் பண்ணணும். ஸோ தீஸ் ஆர் ஆல் எக்ஸப்ஷன்ஸ். மெஷர்மெண்ட்டுன்னு சொன்னால் இந்த ஜீரோஸும் சிக்னிஃபிகண்ட், அண்ட் டெசிமல் பாயிண்ட் வச்சாக்க தென் திஸ் இஸ் ஆல்சோ சிக்னிஃபிகண்ட். ஓகே, ஸோ இது மூணும் கொஞ்சம் கன்ஃபியூசிங்காக இருக்கும். ஸோ ஸ்டடி தம் ப்ராப்பர்லி. இது இப்போ ஆல்ரெடி நம்ம பார்த்தோம். இந்த ஜீரோஸ்லாம் we can ignore. ஸோ 1, 2, 3. ஸோ 3 significant figures. டெசிமல் பாயிண்ட்டுக்கு அப்புறம் இந்த மாதிரி ஜீரோஸ் கொடுத்தாங்க அப்படின்னா then it means we are sure about this. அப்போ this is also significant. significant அப்படின்னா உங்களுக்கு மீனிங் புரியல அப்படின்னா significantனா whether it is accurate or not இந்த மாதிரி. ஓகேவா? So whether we are taking it as an important number or we have some uncertainty. Uncertainty அப்படின்னா whether are we sure about this number or is there any plus or minus value there. That is the meaning of significant figures. 40.00 அப்படின்னாக்க நம்ம இது 2 ஜீரோவும் நம்ம ஷுவராக சொல்கிறோன்னு அர்த்தம். அப்படின்னா this will also be considered as significant figures. இங்கே பாருங்க, இப்போ 0.0 we will not consider it as significant figures. 1, 2, 3, 4, 5. So that means it will be 5 significant figures. நீங்கள் எந்த யூனிட்ஸில் வச்சாலும் சிக்னிஃபிகண்ட் ஃபிகர் அப்படியே தான் இருக்கும். ஃபார் எக்ஸாம்பிள் இப்போ 1.53 சென்டிமீட்டர்ஸ், அப்போ சிக்னிஃபிகண்ட் ஃபிகர் எவ்வளோ? 3 சிக்னிஃபிகண்ட் ஃபிகர். அதே நான் மீட்டரில் கன்வெர்ட் பண்ணால் இட் வில் பி டிவைட் பை 100. ஸோ டிவைட் பை 100னா 0.0153. இப்போ பாருங்க, as I told you, you don't have to consider these zeros. So 1, 2, 3. So again it is 3 significant figure. கிலோமீட்டரில் கன்வெர்ட் பண்ணாலும் it will be divided by 1000. So it will be 0, 0, 0, 0, 153. Again I will not consider all the zeros, only these numbers I will consider, which means it is 3 significant figures. So that means what this tells you is, it does not depend on the system of units. இப்போ சென்டிமீட்டராக இருந்தாலும் சரி, மீட்டராக இருந்தாலும் சரி, கிலோமீட்டராக இருந்தாலும் சரி, right? The number of significant figures does not change. It has to be same. So initially கொஞ்சம் கஷ்டமாக இருக்கும், but as you keep doing it, I'm sure it will become easy. ஸோ பரிமளா புரிஞ்சதா? சிக்னிஃபிகண்ட் ஃபிகர்னா கொஞ்சம் புரியுதா?
எஸ் சார்.
உங்களுக்கு புரிகிற மாதிரி இன்னொரு தடவை சொல்லணும் அப்படின்னா, ஐம் ஷுர் அபவுட் இப்போ 1.53 ஒரு ஸ்கேல் எடுத்து நான் மெஷர் பண்ணுறேன் அப்படின்னா, ஐம் வெரி ஷுர் அபவுட் திஸ் மெஷர்மெண்ட், ஐம் வெரி ஷுர் அபவுட் திஸ் மெஷர்மெண்ட், பட் ஐம் நாட் வெரி ஷுர் அபவுட் திஸ் மெஷர்மெண்ட். அப்போது இட் இஸ் uncertain, but still we'll be including 1, 2, 3. ஸோ 3 இது இன்க்ளூட் பண்ணுவோம். இதுக்கப்புறம் வர்றதுலாம் we are uncertain. இந்த மாதிரி அதுக்கு பேர் தான் significant figures. Exact numbers நீங்கள் மேத்ஸில் படிப்பீங்க. ஸோ you will be studying something called exact numbers. இப்போ ஃபார் எக்ஸாம்பிள் 2πr, circumference of a circle is 2πr. இந்த 2க்கு என்ன சார் சிக்னிஃபிகண்ட் ஃபிகர் அப்படின்னா, it can be written as you wish. இப்போ 2.0ன்னு எழுதலாம், இல்லை 2.00ன்னு எழுதலாம், இல்லை 2.000 அப்படின்னு எழுதலாம். ஸோ you can write it as you wish. Okay. So that's why it's called exact number. Power of 10, I told you, it is irrelevant to the determination of significant figures. So இங்க 10 power 2 இருக்கா, 10 power 3 இருக்கா, 10 power minus 3 இருக்கா, all those things does not matter. What matters is the numbers in front of it. Only that one matters. So இந்த மூணு சிச்சுவேஷன்லையும் significant figure is only 5.70 அப்படின்னா 3 is the significant figure in all the 3 cases. Rules for rounding off, this easy one. I'm sure rounding off already நீங்கள் படிச்சிருக்கீங்க. So we can go a little bit quicker here. Only thing, ஒரே ஒரு rule மட்டும் it might be a little bit confusing, so we can discuss that. For example 7.32 நான் I have to round it up to 2 significant figure. நான் என்ன பண்ணணும், இங்கே ஒரு ஸ்லாஷ் போடணும், 7.32. So you know that 2 is less than 5. இப்போ less than 5 னா இந்த 7.3 அப்படியே இங்கே எழுதிடணும். ஸோ 7.3 sure. அண்ட் இங்கே ப்ராக்கெட்டில் 2 significant figure அப்படின்னு எழுதலாம். ஸோ which means அதுக்கு என்ன அர்த்தம்னாக்கா, இங்கே நிறையா நம்பர்ஸ் இருந்தது, பட் நம்ம 2 significant figureக்கு நம்ம ரவுண்ட் ஆஃப் பண்ணியிருக்கோம் அப்படின்னு அர்த்தம். 8.94 கொடுத்துருக்காங்க. அப்போது if I want to round it up to 2 significant figure, then 4 is less than 5, so that means it will be 8.8, 8.9. 8.9. Okay, 7.26 அப்போ 6 is greater than 5. அப்போ என்ன பண்ணும்? You can add 1, so it will become 17.3. So I'm sure all of you know these things already. இங்க slash பண்ணோம் அப்படின்னா 9 is greater than 5, so that means 8 will become 9, 7.9. இப்போ if I want to round it off 7.352, இங்கே தான் கொஞ்சம் கன்ஃபியூஷன் வரும், so please listen carefully. ஸோ இந்த மாதிரி 7.352 இங்கே நான் ரவுண்ட் ஆஃப் பண்ணோம் அப்படின்னா 5 தாண்டி யூ ஹாவ் சம் நம்பர், அப்போது யூ கேன் ஆட் ஒன் வேல்யூ ஹியர் டைரக்ட்லி. இதெல்லாம் வந்து கிரேட்டர் தேன் 5, ஓகேவா? இது வந்து ஈக்குவல் டு 5. ஸோ ஈக்குவல் டு 5 இருக்கும்போது என்ன சொல்கிறாங்க அப்படின்னா, if you have some numbers followed by it, you can directly add 1. So that means it will become 7.4. Suppose இங்கே வந்து, so you see here 5, 9, so 5 அப்புறம் you have some number, so that means you can add 1, so 18.2 ஆயிடுது. எங்கே ப்ராப்ளம் வரும் அப்படின்னாக்கா, the problem you will face is when you have just 5 and you don't have any other number, or you have some 0 here. 5 அப்புறம் if you have 0, then they have some weird rule. So what they say is, if it is even number, you have to leave it as such. Odd number means you have to add 1. Okay, this is slightly confusing and slightly weird rule. I don't know if people are using this, but this is a rule given in your book, so you have to follow that. So என்ன அர்த்தம் அப்படின்னா 3.45, ஸோ 5க்கு அப்புறம் ஒரு நம்பரும் இல்லை. இப்போ நம்ம என்ன நினைப்போம், we have to add one value, இங்கே ஆட் பண்ணணும்னு நினைப்போம். But what they are saying is, if it is even number, you should not add அப்படின்றாங்க. So you have to leave it as 3.4 அப்படின்னு. அதே நான் வந்து 3.35 அப்படின்ட்டு இருந்தது அப்படின்னா, even though you don't have anything after 5, இது வந்து odd numberன்றதுனால you can add 1, so that means 3.4. okay, so it's a weird rule, but you just have to follow that. So மற்ற எல்லாமே ரொம்ப ஈஸி, இது வரைக்கும் படித்தது எல்லாமே ஈஸி. இது மட்டும் you have to keep in mind that evenனா leave it as such, oddனா you can add 1. ஓகேவா? 8.25 நாக்கா I see after 5 I don't have a number, so that means since it is, I would think I should have to add 1, but even numberன்றதுனால அப்படியே விட்டுணும். இங்கே I would like to add 1, yeah, so since it is odd number, 3 is odd number, so you have to add 1. புரிஞ்சதா? ஏதாவது டவுட் இருக்கா? ஸோ வெரி சிம்பிள். ஓகே, நீங்கள் உட்காந்து ஒர்க் அவுட் பண்ணீங்க அப்படின்னா ஐம் ஷூர் யூ கேன் டூ இட். உங்கள் நியூ புக்கில் இந்த டாபிக்ஸ் எல்லாம் இருக்கா? I think I have a little bit old book. I'm not sure if this is the latest one. Can anyone tell me correctly? In the year is 2000. First edition 2018. Okay. PDF input. Okay, physics 1. Why is it coming as Tamil medium book? Where should I go for English? Oh, this is English medium. Okay. Okay. The book which I am using, how many pages do I have? Here also I have 320, so I think it's the same thing. I just want to make sure that I'm following the latest book edition. Otherwise, you may be thinking that I'm using the old edition. I think we already saw these things. We talked about errors, we talked about error propagation, we talked about these things today, power, we talked about significant figures, we are talking about this table, and then rounding off. Yeah, so that means all these things are there. So whatever I'm teaching you, it is there in your new edition book. Is that correct? Whatever you are having in your book, am I following the correct book? Yes, no, எதுவும் சொல்ல மாட்டீங்களா? Okay. Okay, maybe we can quickly finish this alone. So arithmetic operations with significant figures. So that means when you do addition and subtraction, you have to depend upon the decimal point. When you are doing multiplication division, you have to depend upon the significant figures. இதுக்கு என்ன சார் அர்த்தம் அப்படின்னாக்கா, இப்போ இந்த எக்ஸாம்பிள் கொடுத்துருக்காங்கன்னு வச்சுப்போம். So let's take this example. So 3.1 2. So when you do addition, 3.1, 1.780, 2.046. நான் add பண்ணேன் அப்படின்னாக்கா 6, 12, 1, so it will become 9, 6. So this is my addition. இப்போ என்ன சொல்கிறாங்க அப்படின்னா, அடிஷன் சப்ட்ராக்ஷனில் மட்டும் வந்து we have to follow the decimal point. இப்போ இதில் பார்த்தீங்கன்னா ஒரு டெசிமல் பாயிண்ட் இருக்குது, இதில் 3 decimal points இருக்கு, இதில் 3 decimal point இருக்கு. So the worst case decimal point is this one. Worst case na lowest. அப்போ your answer should also have only one decimal point. அப்போ you have to round it off to one decimal point. So 2 is less than 5, so I will write it as 6.9 and I will write it as one decimal point. So rounded off to, or you can say rounded off to one decimal point. Okay, wow. Subtraction also you have to follow decimal points. 12.637 minus 2.42. So if I subtracted 7, 3 minus 2 it will be 1, 6 minus 4 it will be 2, 12 minus 2 it will become 10. As I said, this is 3 decimal point, this is 2 decimal point. That means this is your worst case. That means your answer should also have only two decimal point. So that means I have to slash it here. So 10.7 is greater than 5. So that means 10.22. Round out to two decimal point. அப்போ எதுக்கு சார் சிக்னிஃபிகண்ட் ஃபிகர்ஸ்ன்னு படித்தோம் அப்படின்னாக்கா that is only for multiplication and division. Addition and subtraction you have to do only, you have to check only the decimal point and round it up to the worst case decimal point. So let's take the examples here. So 1.21 பார்த்தீங்கன்னா வந்து significant figures வந்து 3 significant figures multiplied by 36.72 which is 4 significant figures, which is equal to 44.4312. So you can do the multiplication yourself. Here the worst case is this one. Worst case now, the one which has the lowest number of significant figures. This is the worst case. Your answer should also have only three significant figures. So three significant figures now 1, 2, 3. You have to round it off here. This is less than 5. You can leave it as 44.4. So we can write it as rounded to three significant figures. Decimal point na dp, significant value na s.f. Do the same thing here. 36.72 divided by 1.2. They found it as 30.6. இங்க பார்த்தீங்கன்னா 4 significant figure. Here you have 2 significant figure. That means my worst case is this one. This worst case அப்படின்னா my result should also be should have only 2 significant figure. 2 significant figure na I have to round it off here. So 6 is greater than 5, so this will become 31. Any doubt? இதில் சில பேருக்கு டவுட் வரும், பட் யூ ஷுட் அண்டர்ஸ்டாண்ட் தட் 1, 2 அப்போது இது ரவுண்ட் பண்ணால் தான் இங்கே வந்து 2 significant figure ஆகும். ஸோ அப்போது யூ ஹவ் டு ஸ்லாஷ் இட் ஹியர் அண்ட் சே ஐ எம் கோயிங் டு சி 6 இஸ் கிரேட்டர் தேன் 5. ஸோ அப்போ இங்கே ஆட் பண்ணுவோம். ஓகே, நத்திங் வெரி டிஃபிகல்ட் பட் வெரி இம்பார்ட்டண்ட் ஃபார் யுவர் ஃபியூச்சர் சாப்டர்ஸ். ஓகேவா? அதுக்கப்புறம் we have dimensions. So I think it's already time, so we'll stop here and we'll continue in the next class. Dimensional analysis is also important, very important concept, but easy concept compared to error propagation தான் கொஞ்சம் டிஃபிகல்ட்டாக இருக்கும் இந்த சாப்டரில். மற்ற டாபிக்ஸ்லாம் வந்து ரொம்ப ஈஸியாக தான் இருக்கும். ஸோ ஐ திங்க் we can do this quickly. இது முடிஞ்சால் I think this chapter is over. Yeah. So dimensional analysis we can continue in the next class. Okay, thank you all. Any doubts, please if you have any doubts, please ask me. Any doubts? Are you following? Okay.
No, sir.
Okay, thank you very much. See you all in the next class.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.